Let me start over because I think it might get cut off. This is the third video on forces in motion, and this is about walking. So again, one of the things you're going to need to know is what my mass is, which is about 80 kilograms. You should be able to calculate my weight. And the other thing that we're going to need to analyze is the force of friction, or how friction works, which you saw in the Top Hat module. So if you need to go review that, you should review the Top Hat modules on friction. All right, walking. So I'm going to make some assumptions. Now, the piece of walking that I'm interested in is when I'm looking at my first step. So I'm just stepping off. So I start by standing there, and then when I take that first step, my speed increases from 0 to some walking speed. And I'm going to take that walking speed to be about 1 meter per second. I mean, that seems about right. So a meter is about a little more than a yard, and might be a little bit long, but let's assume that happens in 1 second, the speed it takes me to do one step. Okay, so I go from 0 meters per second to 1 meter per second in about a second. So you can try and figure out what kind of force is needed to accelerate my whole mass from 0 to 1. So you should figure out what the acceleration is. So there's a portion on the worksheet to do that. And then from that, figure out what the force is. But first, you should draw a free body diagram. So draw a free body diagram for me walking, taking that first step, and then calculate my acceleration and the force acting on me. Okay, so you should have paused the video, done that calculation, and then come back to it and started it again. All right. So let's go. Oh, shoot. Let's go find that. Yeah, let's come back. We'll come back to friction in a minute. So here we go. All right. So here's me walking. I take my stepping one leg at a time. I take my first step. And here's the free body diagram. So this is now I simplify my body to my whole, both my feet and my legs and my body all to just one block. I've got the weight pushing down on me. F2, since I'm taking a step, 1 foot is in the air, so I've only got 1 foot on the ground, and that's pushing up. And then the other force that's acting on me is friction between my shoes and the floor. Now, one of the things you should think about is what direction, so take a moment, think about it, write it down. What direction do you think the motion is going to be if the frictional force between my shoes and the floor is directed to the right, as shown in the diagram? So the direction of motion, I didn't write it down here, but the direction of motion is to the right as well. It's in the same direction as the frictional force. If you think about walking, and you think about how your feet work, and you think about you stepping, you're pushing down on the ground, but the ground is pushing back on you, and it's pushing you forward, and it's the frictional force between your feet and the ground that's pushing on you forward. So then, when you work it out, you work it out both in the horizontal direction and the vertical direction. In the vertical direction, you're not accelerating in the vertical direction, so the normal force, the force that was F2 in the diagram, the force pushing up on my feet is just your weight, because you're not accelerating in that direction. There's no other horizontal force other than the frictional force, which is represented here by small f, and that's equal to ma. you should have figured out that our acceleration, my acceleration, going from 0 meters per second to 1 meter per second in a second is 1 meter per second squared. So my acceleration is 1 meter per second squared. So then the frictional force must then be the mass times the acceleration, and so it's got to be about 80 newtons if you work that out, right? MA, because that's what MA is. Now, the other thing that, again, you should have looked at the portion of the top hat that talks about friction. Friction is, and I'll go up here to the frictional force is proportional to the normal force, that is the force between the two objects that suffer friction. So between the floor and the shoe, for example, or between a box and the floor. And times a coefficient of friction. The coefficient of friction doesn't have any units. It's unitless. Okay. Which is something you should work out for yourself, given this relationship here, that the force of friction is equal to the coefficient of friction times the normal force. All right. So when all is said and done, if I want to walk at 1 meter per second squared, I want to accelerate at 1 meter per second squared, which is not a great acceleration, but if I want to do that, then I need a coefficient of friction between my shoe and the floor of 0.1. Right. And that's the last of the 3 videos from the material I had intended to cover today in class.